Today we're going to talk about the formulas for area of a trapezoid, rhombus, and kite. And first of all, we need to make sure we understand what the parts of a trapezoid are. And so we have base 1 and base 2 and the height. And remember, we've said that the base, I'll talk them together. The base of a figure and the height of the figure always have to be perpendicular to each other. Okay, they have to be perpendicular. And so the sides of this trapezoid are not our heights. It's just the green dotted line here is going to be our height. Okay? So, formula. You've seen it before, right? I'm not sure what's going on in my computer today, but it's dragging. One half the height times the sum of the bases. That's the formula for area of a trapezoid. One half the height times the sum of the bases. Okay? Base 1 plus base 2. Make sure you put them in parentheses. You don't want to multiply the h by the base 1 and then add base 2 to it. Okay, here I have a kite and a rhombus. The one on the left is a kite. The one on the right is a rhombus. Okay, we have diagonals for them. By the way, a rhombus is also a parallelogram. So if you wanted to, you could find the height and find the area using the area of a parallelogram. But there's a special formula that works really well, and it looks like this. Okay? Yeah, raise this up a little bit. Was anybody not done with the trapezoid formula? Okay, I'll pause while you copy this. Let me rephrase that real quick. These two formulas mean exactly the same thing. Taking half of the diagonal 1 timesing the answer by diagonal 2, or multiplying the diagonals together first and then dividing by 2 works. And this picture is supposed to be of a kite, but it also works for a rhombus. The same formula works for both pictures. Okay? It's not that this one goes here and this one goes here. That's not at all what I've intended for you to understand about this. Okay? Both these formulas work for both of these polygons. Okay? Quadrilaterals, I guess we can be a little more specific. All right. Any questions on that? Okay? Let's move on then. We have an example of a trapezoid here. And like the book likes to do to you, they didn't draw it the way we normally look at it. Wants to find the area. If we rotate that around, we look at it in a more traditional way. The question is, what's the height of our trapezoid? 4. How do we know that? Okay, so you're looking at this triangle. And you're saying the missing side is 4? Okay, if we don't look at that and see that that's a 3, 4, 5 triangle, how can we solve that to find that unknown side? Pythagorean theorem, that's correct. And so we would say a squared plus b squared equals c squared. And a and b are these unknowns, or this unknown and this side. So let's say 3 squared plus x squared. and C is the 5. So 5 squared. And so if we continue to solve, we get 9 plus x squared equals 25 squared. I'm sorry, not 25 squared, just 25. Then subtract 9 squared from both sides. I'm sorry, 9 from both sides. Boy, I've got squared on my mind, don't I? What do we get? 25 minus 9. Cody, what is that? 16. And then the square root of 16? 4. And so Jackson recognized probably that this is a 3, 4, 5 triangle. I think we talked about that briefly on Friday. The more of these you see, the more you'll start to recognize. Just keep in mind that the 3 and 4 have to be legs. If I gave you a triangle that looked like this, and I said 3 and 5, this side cannot be 4, can it? Because it's hypotenuse. Hypotenuse always has to be the longest side, right? So don't fall into that trap. That's not a 3, 4, 5, but this one is. One leg was 3, hypotenuse was 5, so the other leg has to be 4. To be a right triangle, to be a Pythagorean triple, it's got to be 3, 4, 5. How long is this side? 6, because we've created a rectangle here, haven't we? And so if the top is 6, this is 6. Okay? So the formula is 1/2 the height times the sum of the bases. Again, I would copy it down every time you have to look it up. You don't have to look at it to know where numbers go. You don't have to copy it down. You've already learned it. But if you're looking at the previous problem or back at your notes to see the formula, or in the book to see the formula, then you probably should be writing it down, yeah. All right. So what's the height? 4. What's base 1? 9. 6 plus 3, right? And then what's my base 2? 6. And so again, you can multiply in any order. I'm going to choose to say 1/2 of 4 is 2. 9 plus 16 is 15. And so the area of my trapezoid is 30. I'm seeing I didn't put a unit on there, so I'm at 30 square units. So that's how I would write that. Okay? Any questions on that? I'm sorry, was anybody not done with that? Okay. What is this? A rhombus. How do we know it's a rhombus, not a kite? All 4 sides are the same. Does it matter what it is? No. It kind of does, because in this picture I'm saying the 30 represents this side right here. And the 20 represents this right here. Okay? And in a rhombus, that tells us then what the other halves of these diagonals are. But in a kite, it only tells us one of them. Okay? It doesn't tell us both of them. Let me draw a kite real quick. Won't be perfect, but if I know this is 30 and this is 10 in a kite, we know this is 10, but we don't know what this is. So they would have to give me an angle, hopefully a 30, 60, 90 or a 45, 45, 90, so that we could find that missing side. And then we could finish this. Okay? Otherwise, we don't have enough information. But in this picture, because it's a kite, because it's a rhombus, diagonals bisect each other. Remember the rules for parallelograms? One of them is opposite sides are equal, the other one is opposite angles are equal, and the third one is diagonals bisect each other. And so that means this is 20 and this is 30. Okay? So my formula, how do you like to write it? As a fraction or 1/2 times? I'm hearing both. I heard this one first. You write it the way you like it. It doesn't matter to me. Okay? And so if we write it this way, diagonal 1 is how long? How louder? 30 feet? No. 60 feet. Right? The diagonal is the whole length. So 60 feet, unless you thought it was 40, then diagonal 2 would be what? 40. And if you switch those around, it doesn't matter, does it? And so 40 times 60 is 2,400. 4 times 6 is 24, 2 zeros. Divide by 2, I get 1,200 square feet. Pretty good sized room. Okay. This room is close to 900 square feet. Square feet, pretty good sized room. Pretty small house, so not a bad sized apartment though. You could divide this up. Wouldn't be too bad. All right. Any questions on how to find that? Homework, and I'll give you some